Welcome to this first video on factoring trinomials. So let's take a look at multiplying trinomials. That's sort of the place to start with these problems to understand how unmultiplying or factoring would look like. So let's say we had x plus 3 times x plus 4. And if we were to multiply this out, we get x squared plus 4x plus 3x plus, but I'm going to write this as 3 times 4. And yes, that's 12, but I want you to see very clearly in super slow motion how this works. And x squared plus 7x plus 12. Right? So this is the answer for multiplying. But what if we factor? Well, to factor, we'd reverse the process. So we would start with this and then hope to end up with x plus 3 times x plus 4. Now the key to seeing how we end up there is to notice how you got to 12. The way you got to 12 and this 7, right, is by multiplying 3 times 4 that gave you 12 and adding 3 and 4 to get you 7. Right? So 3 and 4 have sort of double duty. They must multiply to give you 12 and add to give you 7. So when I look at a number like this, I write down all the possible things that can multiply to be 12. 1 times 12, 2 times 6, 3 times 4. And I stop the moment I find a pair that adds to be 7. So the moment I find the pair that adds to be 7, I know I found what I want, because right here I see 3 times 4 multiplies to be 12, 3 plus 4 adds to be 7. And where is this 3 and the 4 in the answer? They go there and they go there. So I could say, okay, fine. So that means that I can write this as x plus 3, x plus 4. Now it doesn't matter whether you write the 4 first or the 3 first, but that's the answer, x plus 3 and x plus 4. In other words, 3 and 4 multiply to be 12 and add to be 7. So 3 and 4 multiply to 12 and add to 7. Now this, we'll do more of these, but this technique only works in problems in trinomials where they say a is 1, and you're sitting there going, well, what is this a? Well, trinomials are written like this: ax squared plus bx plus c. So a, b, and c are the numbers that are there, and so this technique works when this number a is 1. In other words, when you're dealing with problems that are like this. Now we'll deal with the other kind as well, but that will be in the next section. So in this section, all we're looking at is problems where a is 1. Okay, so let's take a look at a few examples now. So let's do another one: x squared plus 12x plus 20, right? So 20. So what are the numbers that multiply to 20 and add to 12, right? So those are that's what we are looking for. So if you don't see it straight up, you can just start at 1 and 20. That's 21. 2 and 10. That's 12. Oh, there it is. So I found my pair. They are right there. So the answer to this question is x plus 2, x plus 10. Okay, another one. Example. Factor. This time, let's take a look at x squared plus x. Let's say, yeah, plus x minus 72. Okay, now negative numbers give people a bit of a hard time because one of the signs is positive and the other one is negative. But you know, don't sweat it, just do the math. So it must multiply to a negative 72 and add to a 1. So again, if you don't see the numbers straight up, just do one at a time. So 1 and 72. Now establish the relationship between the plus and the minus right here on this first step. Now remember, it must add to be a positive 1, which means that the bigger number should be positive and the smaller number should be negative, because no way are they going to otherwise add to be positive, right? And clearly that does not, so I'm not even going to worry about what it adds to. So negative 2, because it's even, and this will be a 36. It doesn't work out. How about negative 3? Negative 3 and 27. Okay, numbers are getting closer, but it doesn't work out. How about negative 4? Negative 4 and 72. I might need a calculator for this. 18. Still doesn't work. Negative 5 doesn't divide. Negative 6. Negative 6 and 12. Nope. Negative 7 doesn't work. Negative 8. Negative 8 and 9. There it is. Negative 8 and 9 multiplies to be negative 72 and adds to be positive 1. So I found my pair of numbers. So that's x minus 8, x plus 9. So again, how do we navigate the plus and the minus? We notice that they're minus there, which means that one has to be negative and one has to be positive because they multiply. But we made the big one positive because we knew that what they have to add to is positive. So that way, if you keep the bigger one positive, you know that that's always going to happen. Let's do another example here. So this one, example, x squared minus 11x plus 30. Well, how do we do this? Well, again, it must multiply to be 30 and must add to be negative 11. Now this is an interesting one. So if you look at the previous example, we had to keep the bigger number positive in order for the answer to come out positive, because they had to multiply to be negative. Now this one, they had to multiply to be positive, yet for all they must add to be negative. So the only way that can happen is if both numbers are negative, right? If both numbers are negative, then they'll multiply to be positive and add to be negative. So again, if you don't see it, you can start with 1. That just depends on how good your arithmetic is. Certainly doesn't have to be 11, so that's not it. How about negative 2? Negative 2 and negative 15. Nope, doesn't give me 11. How about negative 3? Negative 3 and negative 10. That doesn't give me 11 either. Negative 4 and doesn't work. Negative 5 and negative 6. There it is. Negative 11 adds to be negative 11. So the answer to this problem is x minus 5, x minus 6. Multiplies to 30, adds to negative 11. Now, don't forget the GCF idea that we talked about as a last example when we factor by grouping. So example, say you had to factor 3x squared minus 21x plus 18. Now, you might say to me, wait a minute, a is 3, which is not 1. I can't do this problem at this moment. Yes and no. You can actually do this problem. So if you look through this problem carefully, you notice that 21 is 3 times 7 and 18 is 3 times 6. So 3 is in overall GCF. So I could take the 3 out, the smallest power, and then I'm left with this, like so. And for this inner problem, a is indeed 1. So now I'm looking for numbers that multiply to be, they must multiply to be a positive 6 and add to be a negative 7. So let's see, I know since it's positive 6, they both have to be negative. So 1 and 6 right there gives me the first is the answer. So this factors further as 3, x minus 1, x minus 6. Okay, that's it.